So I'm going to start recording. So welcome everyone. My name is Amy Browns. I'm with the Career Center, and we are so excited to have Sealed Air folks with us here today to talk about what they do in the industry and food service packaging. And maybe some of you have been to, we've done a few trucks there. It's just down the road from us, so very close proximity to campus. So we're glad to have both Morgan Stewart and Tyler Major here today. Tyler's a UNC Charlotte alum, so that's exciting. We got some really exciting rankings today for our graduate programs out from the US News and World Report. So if you want to take a look at that, Tyler, your degree keeps going up in value. So we're really excited about that. And we have them here today to talk with us and do this industry meetup as part of our Engineering, Manufacturing, and Energy Spring Career Community Week of Programming. So we have a bunch of other things. I'll put a link in the chat where folks can see what else we have going on this week. We also do have 3 of their Sealed Air employees here in the Career Center today, right now, as I speak. They are here reviewing resumes. So if you want to get off this call, once you're done and head to the Career Center, you could get some feedback from those professionals and experts. They will be here until 2 o'clock today. So feel free to take advantage of that. And they've been busy seeing students all morning, so we're really excited to have them here. Okay, great. Well, I will let Morgan and Tyler get started. I know I am recording this, so we will share that as well. And go for it. We're excited to be here.
All right, well, thank you for the introduction, Amy. As said, I'm Tyler Major. I'm a senior electrical engineer over here at Sealed Air. I am an alum. I got hired on to Sealed Air and also received my PhD in 2018. You can see the very long name of the dissertation there, but if you have any interest in it, it's free through the Atkins Library if you just want to search up my name and have some sleeping material to read. Specializing in embedded PLC, automation, vision, and robotics, and that translates a lot in over what we're doing over here. Let's still see it there.
Hey, my name's Morgan, mechanical engineer by training and trade, but apparently I forgot to edit my sassy entry to the slide as I've kind of moved up from mechanical engineering into engineering leadership. I now do a lot of PowerPoint presentations advocating for our engineering group, budgets, finances, tariff strategy, all that good stuff. But still, at the end of the day, really just trying to fill that innovation funnel so that since equipment projects usually take a couple of years and new technologies take a couple of years to develop, what we're working on today is something that we might be making money on in 2 or 3 years. So making sure that we've got a healthy pipeline pretty much all the time so that we can be making money both today and in the future.
All right. So as a quick introduction to Sealed Air, if you're not aware, our flagship product is Bubble Wrap. That was created in 1957, originally as a textured wallpaper. As a little bit of trivia for you, it did not succeed as a textured wallpaper. Then it was translated over to trying to be a greenhouse cover, also did not succeed as that. But in 1960, they found Sealed Air because they figured out, hey, whenever we are shipping all of this stuff out to the minuscule number of people who are buying it, we don't have to package it or anything. We can just wrap the stuff in the bubble wrap. And that's how Sealed Air was originally founded. Today, we have over 16,000 employees in 117 countries, which is quite large. Our global headquarters, as said, is in Charlotte. We're over by the airport on the west side of the area between Tyvola and Billy Graham, if you guys know that area. The corporate headquarters was actually opened in 2017. Before then, while it was getting built, Sealed Air had quite a presence over in the Portal building, which, as said, we have 3 people over there for today. One of my favorite trivia to always give whenever I'm doing any of these talks is you might have noticed while I was going through the introductory pictures, there is a pond on campus. There are 3 buildings and there's a water feature in the middle of them. We've actually dyed that with an environmentally safe additive to color it Sealed Air blue and trademark the color of our pond. So just a little bit of fun trivia there. So Sealed Air as a parent umbrella company owns a lot of different divisions. What we're mostly going to be focusing on today is the Cryovac brand of it. So Cryovac was bought in 1998 by Sealed Air and primarily focuses on food packaging. For purposes of discussion in a lot of the videos I'm going to show you today, we focus a lot on meat, but it extends beyond meat to other areas such as cheeses. So I'll show you 3 of the main flagship products that we sell today, and we'll take a look at them in a journey of, we have a product that needs to be packaged. What order do they hit the machines at? So the first thing that needs to happen in a process is you have a piece of meat just out on a conveyor belt. We need to put it in a bag somehow. Historically, that has been a very manual process. This is one of our automated solutions, the ALR2, which is a bag loader. It has 2 bays for different sized bags to slot over a product in order to package it. One of the main concerns for our customers is that they're using the appropriate sized bag for whatever product that they are bagging, because if you use a way oversized bag for it, 1, the customer's paying more, and 2, it creates a lot of plastic waste, and no one likes a lot of plastic waste. So in order to determine which bag that the ALR2 should use, it can be paired with a vision system that identifies and sorts the products and the dimensions, packaging requirements, and can intelligently pick each one of the bags. That's a quick overview for it, but I know it's a little bit nebulous. You just look at this machine, what does it do? So I will show you a very quick video of this in action.
These always end up being really choppy via Teams or Zoom. We promise it works better than it looks in this video.
Yep, it is moving at more than 10 frames per second, at least on my end. So as you can see, we inflate one of the bags. It's picking from just one of the 2 bays there, and it is slotting it over the piece of meat, and then it gets conveyed onto the outfeed.
So this is an example of an innovation that it's the kind of stuff we work on here. We have mechanical engineers, electrical engineers, and material science people. We work together on both equipment and material solutions as a joint solution. And so this was an example where not only was this robotic equipment developed to meet a specific customer need, but we actually had to change some aspects of the bags to make it so that it could be easily picked and manipulated by the robot as well. It's one of the nice things about having an organization that has both material science, a service organization, and our internal equipment and automation team. Again, Tyler and I are coming more from the automation side. So if you ask us a lot of complicated film questions, you'll get out of my chemistry background really, really quickly. But it's one of the great things about us is that we have the ability to innovate on all 3 fronts at the same time.
Yep. So a few stats about the machine that you just saw. It can bag up to 23 products per minute. To give you a little bit of a frame of reference, with some trips that I just went on, we were measuring throughput of individual baggers, and it was somewhere in the range of 6 to 9 to 10 at the very fastest products per minute. So this cuts down on a lot of the labor costs that the customer is seeing, and it only requires 1 operator to supervise the machine and potentially do bag changeovers. So another nice thing about this machine is that since it does have the 2 bays, they can be pulled out individually without tripping or exposing anyone to any sort of safety hazard sort of deal. So it can run just completely the whole time as long as you keep at least one of the bays loaded. And again, one of the other bays can be loading in progress while you're still bagging meat. Some of the really good things that the operators love about this machine is that it can deal with products weighing up to 44 pounds. As you saw when the meat was presenting itself, it goes on a very thin conveyor that can hold up to 44 pounds. Imagine if you are a person loading these pieces of meat into the bag by hand all day. That gets very straining very, very quickly. Very, very quickly. So you can take the quoted times and replace 2, 3 people at an operator station, and then have them be at other portions of the plant doing less strenuous activities rather than just twisting and straining their backs out. Okay, so second machine that we're going to be looking at, once it is in a bag, we need to seal that bag somehow. And this is where one of our automated rotary vacuums come into play. This is the AutoVac 86. If you ever have a chance to make it into a meat plant, everyone just calls this the CryoVac because it has all of the CryoVac branding and all of it on it. They never call it a rotary. It's always just, oh yeah, go over to the CryoVac. So the outfeed of the ALR2 would come into this machine. It's just a meat in an unsealed bag. They will put it on one of these white platens, make sure that the open end is across the beige area you see on the left of the white patent. That is a heat seal bar. It will travel along the rotary. A chamber will come down, pull a vacuum. Heat seal bar will seal that closed, cut off any excess bag tail to make sure that it's not just a huge plastic flap hanging off the end and then ejected on the other side of the machine. Some nice things about this is that the HMI that you can see on the screen is fully representative of all of the motion on the machine. It has all feedbacks of what's coming up, what's going down. It even has predictive maintenance of it can tell whenever a seal bar is not performing well or a vacuum chamber is not performing well and can flag that for the operator so they know to skip that platen. Again, I'll show you another quick video of that because things in motion are just always, at least for me, conceptually a lot easier to see.
Introducing the CryoVac brand AutoVac 86, the world's most innovative.
Hey, Tyler, can you mute the audio on it?
There we go.
Sweet. It sounds like a robot, so.
Yep, so you can see the platen coming down on top of the meat and we'll pull a vacuum. The bar will seal it. And on the other side of the machine, you can see on the HMI, it is rejecting it off to the next stage of the process. I'll let it in there. All right, so as I said, it has some predictive maintenance capabilities. So you have the seal bar integrity check, the vacuum chamber check. One of the really nice things, this is one of our new scoping of this brand of the rotary, is that it can control upstream and downstream connected systems. And I'll give you an example of that whenever we see the next machine. But this one operator stationed at here can control multiple machines. So at this point, you have one person who can have an overview of the entire line of production of bagging the product. Now, that does not mean that they're solely responsible for it. It's just they have visibility. So if you ever go into any one of these plants, things can get quite congested and very loud. So the more visibility and awareness that they can have about the things around them, just the better the whole environment is. Okay, so I said we were looking at 3 products. That was a lie. We're technically looking at 5, but all of these kind of get bundled into the same umbrella of shrink equipment. So what we have here, once the product is in a bag, it's sealed, and it's ejected from a rotary chamber, it goes through 2, maybe 3 machines, depending on where the final product is going to end up. And that is a shrink tunnel, a chill tunnel, and a dry tunnel. We'll look at these each individually. So on the left there is the shrink tunnel. So this shrinks all of the remaining plastic around in order to create a very tight seal. Normally, traditionally, you would see a giant hood vent on the top of this connected to some sort of water intake or venting system because being a shrink thing, it uses hot water to shrink the plastic, which creates a lot of steam. This line of tunnels does not require that. We have a proprietary steam recapture system that completely takes that away from the customer. So it's not just dumping hot steam into what's supposed to be a cold environment because you're refrigerating meat in there. Then next, optionally, it can go through a chill tunnel. Customers can choose whether they want to add this or not, but if they are doing any sort of export process, typically it is required that it goes through a chill bath or a chill tunnel in order to meet the export requirements to certain countries. So they just put it in there, honestly, as a inline thing so they can change over their line to do exports if they need it for a system. Also, this is a self-contained system. In the past, if you don't just have a float bath with ice water, you would have to connect a customer's refrigeration system up to a tunnel. Now you do not anymore. The entire chill system is contained up on the top of the machine. And then the final process that always happens, whether you have a chill or not, is a dry tunnel. It gets all of, just imagine you went through a hot waterfall in order to shrink all the product, and then potentially a cold waterfall to chill all the product. Well, at the very end of the stage, you're gonna have to put these plastic bags into a cardboard box to ship them out. You don't want them soaking wet. That is not good for the cardboard. So you have to dry them off somehow in order to get all of that water off without, intentionally cooking the product. All right, that's a very quick overview of just 3 subsets of equipment we have here on the HQ. Obviously, we have a whole lot more, and if you guys want to set up any sort of tours or anything, we're always open to that. The last thing I'll mention before I hand it over to Morgan is that we do have the early career program that we're offering. There are 2 summer internships available here at HQ. Those positions are closing Friday, so if you're interested, then get those submissions in very quick. A little bit longer timeline, we do have a fall co-op positions available. Morgan can speak to how many we're looking for that, but we're looking for all disciplines, ME, EE, computer science. Even if you have a background in data analytics, we have a lot of projects that we can get you some good experience on. As a final note, if any of this does seem interest to you and you do get into the early career program, there is potential for possible field travel. If you want to go visit these plants, if you do end up getting a co-op, I would highly, highly recommend doing that. It's just a really good experience and something nice to put on the resume. And of course, since you're doing a co-op through Sealed Air, you will be paired with one of our full-time personnel, and your flight and hotel will be covered for that trip. All right, with that, that's the show and tell portion of the presentation done, so I'll hand it off to Morgan.
Great, I'll pause it just for a second to see if there are any questions rolling in from the first part. I'm going to try to be a little bit brief and leave more time for questions here at the end. But really the goal of the second part of this presentation is to talk about some of the trends that we're seeing in terms of food automation and food packaging in general. Why do we care? Well, that's what we're here for, right? So the reason that we care a lot about food packaging is because, well, gotta eat every day. And the way that we as consumers are choosing to spend our money when we go to the grocery store, when we order from HelloFresh, when we get a meal kit, when we go to a restaurant, changes over time. As a bit of context and to establish some language for the rest of the presentation, I just want to put these 4 main categories here. When we talk about fresh red meat, we're typically talking about cuts of beef, cuts of pork that you would get. Sometimes the things that traditionally would go to the back of your butcher store and then be cut into your steaks, your chops, all of the different parts there. There's also another format that you're probably familiar with, which would be like a tray over wrap format, where you have like a styrofoam style tray with a plastic over top of that. Again, if you've broken down a product in the back of the house in your butcher store or grocery store, things are often portioned in that tray format. A new, more modern solution is our case-ready solutions. A lot of these are vacuum packaged for better shelf life. We call this product line case-ready because the way that it comes out of the machines that package it is the same way that it would look on the retail case. We even have like a little fake grocery store in our basement down here. So sometimes our testing is going and looking at the different products and just saying, hey, would you buy that? What do you think about that? That sort of thing. So that's what we mean by a case-ready solution. Another area that you might not think about sealed air or cryovac in is fluids. So what I mean by that is box wine, if you're over 21, or it could be things like ketchup, mayonnaise, sauces, anything like that. A lot of those foods that are packaged, or those liquids, are actually packaged in a vertical system where they're pumped and then the bags are kind of made and the products are filled along the way. So those would be our fluid solutions. More things are a fluid than you think there are. For example, Even ground beef can be considered a fluid in certain situations, but we're not going to get into that for this presentation. If you're really into fluids and vertical packaging, I can talk your ear off about that on another time. On this slide, I just wanted to call in some big demographic changes. So one of the changes is everything's expensive right now. And so when things are expensive, people make different choices. Between health benefits or health changes, just the dollar per dollar cost per pound, we're seeing that younger shoppers generally prefer or are buying a greater percentage of poultry as opposed to like fresh red meat products. In that there's brand awareness and that people really want stuff that's going to stay in the fridge for a long time. It's going to stay good. It's going to stay looking on day 21 the same way that it did on day 1. So you have less food waste. You're not throwing things away. And if you're choosing to eat meat, that you're not offsetting that environmental or that you're not also just throwing it away, right? Because there's an environmental impact to the consumption of really any product. And that environmental impact is doubled if you're not actually eating it. Tyler, if you want to hit the next slide. So another trend that we see is continued dominance of case-ready solutions. So again, coming to that case-ready format, that's where you saw the product was highlighted. It was in a vacuum sealed package for extra shelf life. And it had a nice presentation. You can have some good branding on that. And that's just going to be a solution that sits or that's able to sit in your fridge, stay good for longer. And they're prepared on equipment at the customer site or at a processing or packaging site. So one of the differences that creates and one of the opportunities it creates for us as equipment designers is that you're changing where that equipment or where there needs to be a piece of equipment. When it used to be that you were getting these large cuts of beef into the back of your Harris Teeter, your Kroger, your Publix, and then someone was cutting it up, putting it into trays and overwrapping it by hand, that's a pretty manual operation, right? If you're doing that in a production facility and you're creating these case-ready style packages, there's an opportunity for innovation there. Whenever there's a new package format, our materials people can come up with the next great thing. We have to figure out, okay, great, but how do we put the meat in a bag? When we're really frustrated, we like to say, oh man, we could put a man on the moon, but we can't put meat in a bag. And then we get over it and we solve our problems and we move on with our life. But all engineers have those days. So Tyler, if you want to move to the next slide. Again, these are some of the changing trends that we're seeing in the market. Some of these emphasis on case ready for the keeping it fresh longer, for it being a leak-proof solution. No one wants chicken juice in their fridge. But another one that's interesting and has actually grown a lot in the last year or so, so this data from 2024 might already be outdated, is freezer ready. So especially in tight economic times, one of the trends that we're seeing right now is people going to bulk stores. So like what, or buying the bigger package at Walmart or going to Costco or Sam's Club, where instead of just getting the chicken that you need for this week, you're actually getting one of the bigger multi-packs. But if you've ever accidentally frozen a really large package where the chicken's just all on top of each other and then tried to use it, it's a giant unusable block of chicken. So we're seeing a bigger emphasis on products and packaging formats where you're able to divide up the products into the portion that you need for tonight's dinner. So that's like the one that you see in the middle here, where you've got kind of those individual portion sizes. It's still one package. You're still able to buy with that bulk savings, but you're not dealing with a big frozen mess if you were buying in bulk. And again, resealable, keeping things fresh for longer, reducing environmental impact by reducing food waste, and environmentally friendly. Again, there are lots of changes right now in films and what's allowed to be in films, different environmental regulations as well. And so what our material science group does is they innovate and create new package formats to be able to meet and beat those environmental regulations. This one we'll skip through pretty quick. Again, you can see that there are chicken kind of goes up, especially as people, like if we're in uncertain economic times, people make different swaps with their proteins. You'll see cheese, you'll see chicken. Those sort of things tend to go up when beef and pork are more expensive. Next slide. And again, just re-emphasizing, people make choices. If you look at, there's a big customer survey last year of consumers who eat or consume protein products. Over 72% said that they make at least one change in how they decide on what to buy. 49% said what amount. So that might be for lower income families, it might be buying less. So like buying exactly what you need, or replacing some proteins with other like grains or that sort of thing. For higher income households, that might be buying in bulk, but going fewer times. What kind? Again, that's kind of the chicken versus beef, that sort of swap. What cuts? You know, maybe you're not getting filet mignon, but you're making do with something else instead. And where purchased, like, are you buying the store brand? Are you buying a name brand? That sort of thing. So all of that's about how it actually affects our customers. How does that actually affect us as equipment designers and in the food automation space? So while all that's going on, while people are deciding what they're going to eat for dinner tonight, we have to figure out how to get them what they want to eat on time, in a safe manner, with a great taste, great value. And frankly, all of these companies are for-profit companies. Got to make a dollar while we're doing it. Some of the trends that we're seeing in the industrial food packaging space are consistent interest in automation, emerging solutions in vision system and robotics, offset by a capital constrained environment, which puts pressure on people being able to put in purchases. So what do I mean by that? I mean, everyone seems to think, all right, robotics, that's the next big thing. Vision systems, AI, that's the next great thing. We want all these products in our plant. And then we quote, all right, great, we can do that for you. It's going to cost this many dollars. And they're going to say, well, I don't have that today. So as engineers, some of the constraints that we work with is providing a mix of solutions where we have some things that are highly automated solutions that can save on labor, that can reduce risk if you're having lots of labor turnover. But those are more expensive. We also have to have solutions that are what we call like semi-automatic, which is kind of a combination of people and machines to be able to make a job faster or more efficient. And we still need to support our manual operations. So people who are putting products in a bag, how do we make their job safer, more ergonomic, more efficient? So that again, we can reduce employee turnover and create a more consistent food supply chain going forward. This is something, the cattle cycle is something, if you want to really nerd out, you can start asking ChatGPT or Wikipedia about the cattle cycle. Basically, when you talk about companies and innovations, you always think of startups, right? And software companies, and they can innovate really, really quickly. We don't get to have that iteration cycle, especially in the hardware automation space. Like, it takes a long time to build something. And in the food automation space, specifically proteins, not only are we dependent on a physical product, but we're dependent on a physical product that takes 3 years to grow up to the point that it can be harvested and turned into product. The cattle cycle is an interesting phenomena to look at because there's all these market dynamics between the supply of cattle, like the herd size you'll see, and the price, and then how many products are being produced. Right now, we're in a tricky spot where we're in one of the smallest herd sizes that we've had. And so especially as we have pressure due to tariffs and import and export restrictions, there's a lot of uncertainty within the industry on what the future is going to look like in terms of the price for cattle, which then turns into the price that you would pay at the grocery store or at the restaurant as well. Again, part of our job is to anticipate those trends, to work those into our innovation cycle, and for us to understand, hey, this year a customer might not have the money to buy this super automated system, but in 2 years down the line, they might. If it's going to take us 2 years to develop that system, we need to be designing that today. You've heard a lot about tariffs. If you've been following the news, tariffs heavily affect the food industry as well. Tariffs, as well as just any general import and export restrictions. One of the things to watch out for, again, with the protein market is that we have a product that can get sick, or that we have a product that can be affected by weather. Like the price of grain goes up, it gets more expensive to raise a herd of cattle. So one of the things that we're seeing in the food industry right now is a rebalancing and people reconsidering, hey, how much product are we exporting? Do we need to keep that within the US? Is China even going to, are they going to, does it make economic sense for us to export product to China? Like the plant in Tar Heel, North Carolina is the biggest pork producing plant in the world. That means that there's a lot of export operations in the protein market from the United States. But as we have these complicated global dynamics, it creates some uncertainty on pricing. And then that's something that I take as an input to my job on where do we build our equipment? We have a machine, the BLR2 is actually manufactured in Switzerland. You know, should we be building that in North America instead? Well, it would take 2 years for us to tool up as an engineering org for us to be able to actually build that here. Does that make economic sense? And then for our customers, they have to choose the mix of products that they're selling internally within the US, and then what they're choosing to export as well. Another way that that impacts our equipment is, for example, Tyler talked about the chill tunnel that primarily meets export regulations, or is primarily purchased to meet export regulations. If you have less export demand, then you're going to have less demand for those products as well. So it all comes back together. I never thought that I'd have to be as in tune on politics to be an engineering manager as I am, but that's the job. So, and how do we mitigate all of this uncertainty? Continuing to innovate, right? The problems that we have today are not the problems that we're going to have tomorrow, but we look at them as best as we can with the lens of the information that we have. And we try to keep a view that, hey, we can't be reactionary today. We need to make long-term strategic plans that move our area of technology forward, that we start looking at AI and vision systems and figure out how do we baby step a very old school industry where maybe the maintenance team right now just has a wrench and a hammer. How do we help to train them and come together with our customers as a partner to bring them on this journey to be able to accept more automated solutions in the future and create a safer, more secure food supply chain, so we can win both, you know, as a company with our customers, and so we can have great dinner. Tyler, I'll have us skip the rest of the slides and then just open it up. Are there any questions?
I'm sorry. If anyone has any questions, you can put them in the chat or raise your hands.
I've also been told that I talk way too fast on Zoom calls. So if there's anything that I rush through quickly, happy to revisit.
I had not thought about like thinking about the tariffs and those kinds of things. Do you guys feel that it's kind of really disrupted your industry? Obviously, you're spending a lot of time kind of trying to figure out with a crystal ball, I think like everyone is. But are you having lots of conversations with customers, or not you particularly, but potentially your sales or your business development teams?
Yep. The good news about this, if there's good news about uncertainty, right, is that we are, the tariffs are in some ways hey, we heard that they were potentially coming and we were able to make a plan, right? So I think that there are a lot of folks on the team that have whose jobs have kind of turned into creating the playbook and then executing the playbook. So I think that we're preparing well and then continuing to execute as more and more information emerges. But yeah, it's certainly, it wasn't, when I signed up to be a mechanical engineer in 2015 and graduated, right, I never thought that I'd be looking at global market dynamics as much as I do now.
Yeah, everything's so connected in your global footprint for sure. Yeah, it's fascinating. We do have a question. How do you guys prevent cross-contamination when sealing foods? And when working with meat, how do you ensure the temp control?
For sure. So there's a set of equipment standards that we use when we're designing pieces of equipment. So not only do you have to design to all of the normal good machine design standards, you also have to design your equipment to be able to be cleaned. In North America, the way that cleaning typically goes on is there's large high pressure hoses with hot water, cleaning chemicals, that sort of thing, that are used to clean the equipment overnight. So that becomes a serious design factor for us to be aware of when we're designing the equipment. Like you can't use materials that are going to be eaten by these cleaning chemicals, that sort of thing. When you're sealing foods or sealing plastics, one of the big things to do is to make sure that you don't have purge or like any liquids in that area, like liquids, fats, really hard to seal through. But that's also where like having a quality person or a quality system checking the products before they go into a box helps to make sure that like if you were to try and seal through a fat and it didn't seal well, you'd be able to detect that and then send the product back through for rework. In terms of temperatures, most of the plants are refrigerated. So if it's a raw meat plant or a raw protein plant, then it's going to be a cold room plant, which again, things I didn't know when I signed up for this job. I actually started in the bubble wrap side of the business, which has no refrigerated work. But our equipment goes into cold rooms, cold environments. And then the temperature of the product is maintained throughout the entire process. Is the working environment cold? Yes, at an actual packaging plant. And we have some rooms here in our Charlotte lab that can be made cold. So they've got big like chiller doors, and then we have an HVAC system that can make that room cold. 90% of the time, we're not working in the cold environment, but if you're on a product that's being tested or we're doing throughput testing in the lab, those are my least favorite days. We do have full jumpsuits and like lots of coats and stuff, but frankly, those are not the best days.
Again, something you wouldn't think about necessarily in with your role specifically, but yeah, it makes sense. Great.
Yep.
Any other questions? Well, I went ahead and put the links to the positions that Tyler and Morgan mentioned. They're in the chat. So, hello. Oh, sorry, I just lost my screen. Just went completely black for some reason. So those are there. We want to thank Sealed Air and Morgan and Tyler, and hopefully we'll get a truck scheduled in the next year or so to come back. We've been there before, and it's always been a really interesting and fun experience for our students and for us too. So thank you, everyone, and enjoy the rest of your day.
All right,
Thanks,
you
y'all.
for having us.